Hey everyone, and welcome to our second lecture video on functions. In this video, I want to keep building on what we learned about previously and try to gain a deeper understanding of functions. We'll also take a look at some optional things that we can do with functions that are pretty neat. So let's go ahead and jump on in. First thing I want to talk about are function stubs. So function stubs are helpful when it comes to incremental development. Let's say that we knew that we're writing a program and we know that we want to write a particular function, but we're not ready to implement it just yet. Well, we may make a function stub for that. And a good example is right here in this screenshot. I have a function feet to inches that takes feet as a parameter. And the function body simply returns the inches. And then I have this feet to millimeters that takes feet, but I may not be ready to fully implement this yet. Maybe I need to look up the formula, or I'm just not at this point in the program yet where I want to write this function body, and that's okay. What we can do is we can go ahead and write a stub that defines the function. So we had the function name defined, the parameters, and for the body we can use this placeholder of pass. So what pass does is it really does nothing. If this function gets called, it executes pass, nothing happens, and it just simply returns back. So in our code, we can go ahead and actually start using this function. Maybe we were fleshing out what our main code was going to do. Then later on, we can come back and implement this function body, and main will work just fine. Now, another option is to implement this or raise this not implemented error. So when we raise something like an error, that's where we get that trace back in our console, and we've seen those with name errors and value errors and things like that. A different type of error would be a not implemented error. So as an alternative to just writing pass in our function stub, we could say raise not implemented error, and then if anywhere in our code we call that, like we do on line 9, when the interpreter hits line 9, it's going to actually throw this error. It's going to stop the execution and say, hey, this hasn't been implemented yet. We can actually see that here. If we were to go and run that, we get this not implemented error. So when it comes to functions, functions are also objects in Python. So we can pass functions around and we can assign different aliases to them. And we've seen previously how different data types all have a type, an ID, and a value. So if I define a function like x here, and it doesn't really do anything, it's just a function stub, so I just have pass written. But we can look at the type of it, and we can see that the type of x is a function, and the ID, which corresponds to the memory location, is located here. And the value, if we were to just type in x and press enter, it just gives us this nice little printout showing that function x is at this memory location. So what really happens behind the scenes are this function gets compiled down into bytecode, and that bytecode is what gets executed when we call the function. Now remember, to call the function, it's not enough to just say the name. We also need to use the parentheses behind it to indicate that we're calling it. So an example of aliasing here, we have this function x, and then I create a variable y and set it equal to x. Well, if I call y, it's really the same thing as x, and it's going to call this x function and print x. We can also tell that they are the exact same function because if we look at the ID is the exact same. So x and y are both pointing to the same function in memory. And then speaking of compiling down to bytecode, so bytecode is similar to assembly in that it's a lower level form of the programming language. And if we look at this simple function on the left, this add1x that computes what x plus 1 is, assigns it to y, and then returns y. Well, we can see that happening over here in the bytecode too, and this is what this program or this simple function gets compiled down into. So we have a load fast 0, load constant 1, a binary add, so that's x and 1 gets added together, and then it stores it, so a store fast, it stores into y, then it loads y and returns it. And it's not important for us to understand what the bytecode does, more so that it's important that we understand that our program is converted down into bytecode, and that's how it's ultimately executed by the interpreter. So some common errors that we'll come across as we're writing functions are a copy and paste error and forgetting or missing the return statement. So both of these very common. Here's a little example. If we had a function that converted Celsius to Fahrenheit, and let's say that we were going to create the inverse of that function, so we wanted to create one that went from Fahrenheit to Celsius, well, there's a few things we would need to do. We would need to change the parameter, because in this one we're taking Celsius and converting it. In this one we're taking Fahrenheit and converting it. We would need to change the formula that we use. So it looks like we did that here over on the right. But we may forget to do something like change what's actually being returned. So what should be happening here is we should be returning cell, because that's what we calculated, and that's the intentions of the function. Another common error would just be forgetting the return statement. So maybe we are writing a function that converts steps to feet, and we take steps and we're saying, okay, there's 3 steps in every foot. Let's do the formula and figure out how many feet. But at the very end, we never returned anything, so when we call it on this line, nothing gets returned to feet, and if we print it out, we see that it's none, or that none type that we talked about in the previous lecture. So next I want to go a little bit deeper into function arguments. So when we pass in function arguments, they're passed by assignment. Similar to up here, when we looked at this y equals x, this is just an assignment, and we see that they ended up actually pointing to the same data structure in memory, the same function. So let's jump over here and sort of revisit a topic of immutable data types. So these are data types that do not change in memory, meaning we cannot modify them in place. Instead, we have to create a totally new one. So some examples of that would be ints, strings, floats, tuples, bools. And in the screenshot here, we have a good example showing that we have a function called foo that takes one parameter bar, and all it does is just reassign bar to be 0. Now, since bar and x that's getting passed into foo here, since they are integers, they're immutable. And what that means is, here on line 5, x equals 1. If we call foo and pass it x, then this 1 gets assigned to bar, or basically bar equals x. And then when we say bar equals 0, that actually throws away or pretty much reassigns bar with a new object that's 0. Okay? And what I'm getting at here is that the value for x when we return never changed. So x is still 1 even after line 6 executes. Now those immutable data types are in contrast to mutable data types or mutable objects. These are ones that can change. So some examples that we've seen are lists and dictionaries. An example in real life would be the weather. So here we have a very similar example where we have foo defined, it takes bar, and it looks like it intends for bar to be a list because what it does is it sets the 0th element to 2 and the first element to 3. Now if I have a list already called nums that's set to 0 and 1, and I pass that to foo, then bar equals nums. They are going to both point to the same list in memory. So that's what we're showing down here. They're both pointing to that same list. And as soon as it enters this function, it sets the 0th element to 2. So originally with nums, the 0th element was 0. But bar then goes in and says, okay, I'm going to change your 0th element and I'm going to set it to 2. And then it also goes in and changes what's at index 1 and changes it to 3. And what happens here is slightly different than what we saw before. Rather than nums being unchanged, nums is actually changed when we return from line 6. And if we were to inspect it, we would see that nums now equals 2, 3. Okay, so the big takeaway here is if we're passing an immutable data type, when we return, what we passed in won't have changed. But if we're passing a mutable data type, like a list in this case, it is possible for the function to modify that and for those modifications to be reflected or seen when we return back in the program. So default parameter values. This is a pretty neat little feature of functions in Python in that we can specify parameters, but we can also have them be optional for the caller in that if the caller doesn't specify it, it'll just use a default value. So here's a simple example where we defined a function called print word. It takes one parameter word, and you'll notice that a little bit different than how we normally write a function. This says word equals hi. So all this does is just print out the word, and basically if we call print word and we don't specify the word to be printed, then it's going to take this default value of hi. So line 4 would print out hi, and then line 5 would print out bye because I'm actually specifying a word this time. So the default value is only going to be used if we don't specify an argument. Now another way that we can call functions is we can explicitly set what the parameter variable is supposed to be. So this is just another way that we can call functions a little bit more flexible. We can change the order if we want to. So I have this function here, send email, that takes 3 parameters, to, from, and message. And then on line 6, you see that I'm calling send email, but I'm specifying the message first. I'm saying message equals hi, it's from this sender here, and I'm sending it to this receiver. So as long as we specify all 3 of these parameters, it doesn't matter what order they're in because I'm specifying them as keyword arguments. I'm saying exactly what they should be set to. Now if we start off not specifying keyword arguments, like on line 7, here I'm specifying the receiver first, but I'm not saying that 2 equals receiver, then it needs to go in order from left to right. And as soon as we stop doing that, we have to specify keyword arguments. So here receiver lined up with 2, but then I went ahead and said, all right, message equals hi, so that's actually my third parameter, and from equals sender, and that was originally the second parameter. It's also possible to specify just an arbitrary number of arguments. So there's 2 ways we can do that. One is with the star args, and that's going to allow us to pass in any number of arguments that we want. Then there's also the star KW args, and the name actually doesn't matter here. So args, KW args doesn't matter. That's more of a convention that we use that. What's important is the star and the star here. And I think that'll make more sense when we look at the example. But the keyword args creates a dictionary named KW args, and it allows the user to pass in any number of key value pairs. So let's look at an example of that. So here we're defining this function called sandwich, and the sandwich has to take bread, it has to take meat, and then it has this star args, which means that we can pass in any number of extra parameters that we would like. So if we go and we call this down here, we can call sandwich. So the bread is sourdough, the meat is turkey, and then the star args is mayo. So what args is inside this function, or inside the function body, is it's really just a list. And we can iterate over that list and print out all of the extras that we would like. So we'll see the first output here is turkey on sourdough. That comes from our first print statement right here, with mayo, because that's the only extra args in that list. But then on the next line we see that the bread is wheat and the meat is ham, but we have 3 extra args specified: mustard, tomato, and lettuce. And as we iterate over that list, we just end up printing them all out. So ham on wheat with mustard, tomato, and lettuce. So what this boils down to is if we put a star args, it has to go at the end of our function, because we're going to have an arbitrary number, as many as we would like, or 0 if we would not like to pass any in. And whatever gets passed in extra will be placed into a list called args. KW args acts in a very similar way. So what this allows for us to do is specify almost like we were before with those so jump back here, like we were with the keyword arguments, but the arguments themselves, or the parameters, haven't been defined yet. So these are extra ones that we are defining. So same sort of example, we got our sandwich with our bread and meat. Now we're saying star KW args, and we're printing out the bread and the meat, so ham on wheat or whatever. And then we're looping over our keyword args, which we can see is just a dictionary. So we're calling that items method on it. We know that that's going to return a list of tuples based on the key value pairs. So we have a category and an extra, and it makes a lot more sense when we look at how it's being called down here. So they're specifying the bread and the meat, and then our keyword args dictionary, our key is sauce, and our value is mayo. We can specify as many of these as we would like, it's just going to create a dictionary out of them. So one more example of that, and this is a good job, I think, of showing how we can make functions a little bit more abstract. So this one is generating a command. If you've ever messed with the command line, you can run programs on the command line, and you can also specify some optional parameters at the same time that, in this case, maybe is calling PowerPoint, opening up this press.ppt, starting the presentation on slide number 3. All right, so basically what they're doing is they're taking in an application saying, okay, that's the command, and then they're building up this command line from it based upon these optional keyword args. So just to reiterate, we don't have to specify any keyword args. We could just specify the application and everything's going to work just fine. We just see notepad.exe. Essentially, when it goes to loop through the keyword args, it ends up not having any, so it skips over this for loop and just returns the command. But on this next one, our application is PowerPoint, and then it's going to loop through all of our keyword args. So if we loop through a dictionary, and we're not doing what we did here where we called .items, instead we're just looping through the dictionary, argument is going to be our keys, or we're going to iterate through all of the keys in the dictionary. So here's our key, and we can pull out our value by referencing the dictionary, keyword args, and pulling out that key. So that builds it up, just tacking it on to the end of this command string using the plus equals. And we can see when we call that with our file equals and start equals and slide equals, that it ends up building this command line up for us. So those are things that I encourage you to play around with. One thing that may help is if you type up these examples and then try running them in a debugger or in the Visualize Python tool, you can see exactly what kwargs is once you step into this function. And I think that kind of helps to visualize that really it's just a dictionary at that point. Or in the case of args, it's just a list. Alright, so what if we wanted to return multiple things from a function? Well, a function can technically only return one object, but an object can hold multiple things. For example, a list can hold many elements. A tuple can also hold many elements. And in fact, a tuple is used a lot if we want to return multiple things from a function. So we've already sort of hinted at or learned about tuple unpacking. And we can see that used down here on line 6. So total comma average equals the sum average of these numbers. And what we're returning is a tuple. So when we do tuple unpacking, this sum underscore will be assigned to total, and this AVG will be assigned to AVG. So what is this function doing? Well, it's a function called SumAverage that takes an arbitrary number of arguments, and it basically just computes the sum of those arguments. So however many numbers we pass in, it's going to sum those up for us, and then it'll average it for us. So it'll take that sum and divide it by the length or the number of numbers that we passed in, and then just simply return it as a tuple. And what you'll see is we ended up being able to return 2 data types inside the tuple, essentially sidestepping the fact that we can only return one thing. So this last little bit just has to deal with generating help or documentation for our various functions. A docstring is a string literal that's placed right after the function definition. This shouldn't say body, it should say definition, or it should say right before the function body. So there's no blank lines before or after, and it's always a triple quoted string. So what is the docstring for, though? It tells us a little bit about the function. Depending on how elaborate we want to get with it, it can be just a simple description of what the function does, or it could go into a little bit more detail as to the description and then what each of the parameters are for and what the return type would be. So let's see an example of that. Here's our sum average function again, and at the beginning we have this docstring that says that it returns the sum of average, or the sum and average of args. Okay, so that sort of lets us know what this is doing. If we're going to peek into the source file, these might be nice to see as a developer. We can also use the built-in help, and the help will print out docstrings for us. So real quick, let's look at an example of that. If I open up idle here, so we can use the built-in help inside of our interactive prompt. Anytime we run help, we can actually drop into the help utility, and when we're ready to get out, we just type quit. So we can start typing some functions in here, and it will tell us how we can use them. So for instance, print, and it tells us all about the arguments that we can specify, what some of them do, some of the optional keyword arguments that we could specify. Another one might be sum. So sum takes an iterable object like a list or a tuple and then returns the summation of it. But let's quit out of here for a second, and let's say we defined our own function like sum average that takes an arbitrary number of arguments. And let's say this returns the sum and average of args. So we have our triple quoted string. We call this a docstring, and it's located right after the function definition and before the function body with no spaces or no line breaks in between. So the first thing we might want to do is go ahead and calculate that summation. And then let's calculate the average. So that's going to be the summation divided by the length of args. And then we'll just return sum in AVG inside a tuple. Great. So if I was using this code, and we can sort of imagine maybe it exists in another file and a different programmer wrote it, and I've imported that file here and I'm ready to start using some of their functions, I may want to use help to find out what sum average does. And we'll see that it actually uses that docstring in the help system and it displays it to us. So it's more than just opening up the source file and seeing it there. The fact that we have it there also means that we can use built-in help, or there's other tools that will generate documentation based upon these docstrings. It'll generate like a really nice looking HTML page similar to what we see when we go to docs.python.org and we're looking at some of the functions there. Alright, so that's it for this lecture. I hope you enjoyed the labs and exercises this week. If you run into any issues or have any questions, please feel free to let me know.